Okay. Welcome everybody. Thanks for braving the beautiful weather here in paradise that we got for you. Hopefully we'll have this workshop be worth your time. I think it will be. I just want to take a couple minutes before we get started. I know our time with Rick's going to be precious, so I won't take very long at all. But I just want to give our elevator pitch about the center that sponsors these workshops and just kind of tell you what we do. Um, so I'm Paul Schultz. I'm a statistician and data scientist here for PDHP. That's we conduct these workshops. PDHP stands for Population Dynamics and Health Program. It's a center within the Population Studies Center here at ISR. So our center is charged with supporting and advancing population research here at Population Studies and here at ISR and also across campus. So that's what we're charged with here. We do have some free resources that are publicly available. One of the big ones is this workshop series that you're experiencing right now. I think we did 8 in 2019, and we're planning a pretty full schedule again for 2020. We should be able to do 9 or 10 next year. We'll be on holiday break from now until January or February, but we will start back up in winter here. So that's our big one. We also do a publicly available coder space. It's actually this morning right across the hall in 1450, where it's just sort of like a networking and coding kind of space, similar to what you'd have in a coffee shop. We just do it weekly. People can come in with questions if they have sort of data science or statistical questions or statistical computing questions. We handle those. You don't need a question. You can just come in if you prefer to work in a more social environment. It's like I said, it's really just to get to know each other and kind of help each other figure stuff out. So we do that again every Tuesday, 10 to 11:30, right across the hall here in 1450. So, feel free to stop by anytime. This morning I'll be here. Chen, who works for PHP, will be over there handling the coder space. So it's a little bit of an atypical day for us with the workshop, but in a normal week, we'll both be there. So we're just sitting there for the hour and a half to just meet and greet whoever's there. We also have a small grants program. We just closed a funding round on November 1, and so we won't be posting again until winter or springtime, but we do have small grants that are available to faculty campus-wide as well. You don't need to be an affiliate of our center to access our small grants program, so please take a look at that. Information's on our website. And then in addition to the publicly available resources, we also have additional resources that are available to only our affiliated faculty. So we are charged with supporting population research, specifically with early career scientists. And so we have an affiliateship program for our center where you can apply to become affiliated, and then you get these additional resources such as free consulting from Chen and I. You can request our time if your project has needs that arise above and beyond what we can handle in a few consulting sessions. You can actually book a fraction of our time and pay us to actually do the work for you. We have a mentorship program where you can apply and to have a formal mentor-mentee relationship with a senior faculty member to help develop your career. And then we also do. There's one other one. What am I forgetting here? Anyway, the resources are all on our website. If you would like to become a faculty affiliate, or you work with someone who you think would like to do that, you can contact me anytime, or you can get the details on our website. It's all up there. So that's that. As far as logistics for today's workshop, if you're in the room, great. I'm glad you made it. We'd like to have people here in the room with the weather. I was a little bit worried, but we'd like to have the active participation here in the room. I have an orange folder up here that I'll be passing around probably at the first break, maybe in an hour. I'd love for you to sign in. There's a sign-in sheet in that folder. Please sign in. This helps us track to our funder, the numbers we're getting and who we're serving. And then I also have a feedback form in that folder. Again, we've only done these workshops for a year, and we're in year 3 of the center. So feedback is very valuable to us right now in this early stage to help us kind of shape what we're doing, shape future direction for the workshops, as far as the structure, the format, the topics that we're going to do. All that stuff, we'd love to hear from you, and the best way to do it is to fill out this feedback form. If you don't want to do it on paper here today, I will send you a link, and you can do the same form online later. So again, either one. Either do it today or do it later, but please do it if you don't mind. And I'll pass that around, and please just sign in, and also just take a feedback form if you don't mind a paper form. I believe that's it. Oh, for people on Blue Jeans, you're able to actively participate as well. You're muted on both audio and video by default, but I'll be monitoring the chat. So if you have questions, please type that question into the chat box, and I'll relay it to the speaker, Rick. So I think that's it. Any questions about today? Yes.
Are these slides available for us?
Yeah, the slides are online. If for anyone who RSVP'd, I sent out an email about 5 o'clock last night. We have a web page set up linked pdhp.isr.umich.edu. If you go to the workshops tab, you'll see this workshop on the splash page, and then there'll be a link on that page for video and slides. That page will have the slides. It has has all the R packages that will be used today, and a link to all the data sets and everything that will be used in the workshop. So for those doing it today, if you're doing it today here, great. That's the page for you. If you're going to do it later on your own time, the video will be online, and you'll have everything you need to sort of recreate this on your own later. Again, all from that same page. So anything else? Okay, great. I will go ahead and introduce our speaker today. Dr. Richard Valiant is a research professor emeritus at the University of Michigan and the Joint Program for Survey Methodology at the University of Maryland. He has over 40 years of experience in survey sampling, estimation theory, and statistical computing. He was formerly an associate director at Westat and a mathematical statistician with the Bureau of Labor Statistics. He has a range of applied experience in survey estimation and sample design on a variety of establishment, institutional, and household surveys. He is also a fellow of the American Statistical Association, an elected member of the International Statistical Institute, and has been an editor of several statistical journals. So yeah, we're very lucky to have Rick today. Please help me welcome Rick to the podium.
Thanks, Paul. Just to reiterate what Paul said, please ask questions. I mean, this is for your benefit, not mine. I feel like I sort of know the material already, so don't hesitate to hold your hand up here, and people online too. Paul will see those questions, and we can stop and talk about them. So here's the things that I plan to cover. Basic steps in weighting, weight calibration, and non-probability sampling. And I'm guessing we'll come close to running out of time before I get much on non-probability sampling. But it is sort of a topical thing these days, so it's worth mentioning. And in a way, the nice thing about it is the techniques that are applied for weighting these non-probability samples really are covered in things like non-response adjustment and weight calibration that we'll talk about earlier. So, I should say it's nice to be in Ann Arbor. I like Ann Arbor, although I had forgotten how close it is to the Arctic Circle. So here are the things that you need to get the most out of this workshop. Most of the examples I'm going to show you are in R. There are some in Stata, and I'm not going to open up Stata and run anything. I don't have Stata on my laptop, for one thing. And R seems to be maybe more popular among most researchers. So how many of you use R? You can raise your hand remotely, but I won't see you out there. How about Stata? Uh-oh. Okay. This better? Maybe. All right, so I'm going to use base R and several R packages. This Prac Tools is the thing that I wrote that goes with this book, Practical Tools for Designing and Weighting Survey Samples. I think I've got it here somewhere. There. So, I'd recommend you buy at least 3 copies of this thing. One for home, one for work, one for in the car to come to work. And That way you'll be totally covered. There's another one that I'm using examples from that's called, it is based on Stata. So it's called Survey Weights, a Step-by-Step Guide to Calculation. And I really don't consider myself a good Stata programmer. I mean, it almost killed me to learn enough to write this book, in fact. So I've got a few pieces of Stata code in the slides, but don't query me too closely about those. It was hard enough to figure it out 3 or 4 years ago when I worked through this stuff. And Jill Deaver, who is at RTI, is a co-author on both those books, along with, on this one, Frauke Kreuter. They should get credit. All right, so you should have access to the slides, and then there's an examples file called examples.zip that I think Paul posted. Is that true?
Yep.
Okay. That's got both Stata code and our code. So if you want to repeat some of these examples, all that code should work, and you can just copy it and execute it. All right, so basic steps in weighting. What I'm going to do is start with probability samples, although, these days, saying you got a probability sample is sort of a dubious proposition because we're hit so hard with non-response. Telephone especially is almost, it hasn't disappeared as a method of doing surveys, but the response rates are down in single digits now, and even household surveys are having trouble. Like the health and retirement study that Michigan does has had decreasing response rates over the last few years. And that's, it's not Michigan's fault if that's happening. It's happening to everybody. People are just tired of surveys. I mean, every time you hit a website, something pops up, says you want to take a survey about how we're doing, and you wish there was a button there that says no, and don't ever ask me that again. But still, these methods we feel like apply, even if response rates are smaller. So there's 4 general steps in a probability sample. You calculate base weights, your inverses of selection probabilities. You make an adjustment for unknown eligibility, which I'm not going to talk about much, but what happens in some surveys is you can't determine whether your sample units are actually eligible for the survey, like in a phone survey. You've got a list of numbers that you think are residential, and there are some that you may call and call and call, and there's no answering machine that picks up. You don't get a message that says it's a non-working number. It just rings and rings, and you're unsure whether it really is an in-service residential number or not. So the idea in this second step is just among the ones that you know about, their eligibility, you distribute the weight of the unknown eligibles. And then there's a separate step of non-response adjustment generally, and then calibration to POP controls, which includes things like post-stratification and raking that I'll talk about. So this is a flow chart of the general steps. So let me make it bigger. You start at the top, draw a probability sample in this setup. You compute base weights in step 1 here, which are the inverses of the selection probabilities. So you got to keep track of that. You don't want to let those drop out of your pocket. You pick a nice sample and you don't have a record of how you did it, then you're stuck on this step. Then you drop down here and you make this decision about whether you've got units with unknown eligibility or not. If you do, then you take this branch and make an adjustment. If you don't, then you can just drop down to non-response adjustment. So let me drop down. And there are various ways of doing that I'll tell you about. So if we do have non-respondents, the answer is almost always yes in a survey. You adjust the weights of the eligible respondents. In the previous step, if you had ineligibles, what you do is they essentially drop out. And you adjust the weights of the known eligibles, which will include respondents and non-respondents. So you get down to this step and you got respondents and non-respondents, you adjust the weights of the respondents. And then you store file and go down here and post-stratify if you've got the wherewithal to do that. Now, kind of a key step all along here is don't let these things drop out of your pocket. I mean, you write out subsidiary files. You don't lose track of anything. With the known eligibles, you write those out to a file and save them. The known non-respondents who are eligible, you write those out to a file and save them. Because the thing that inevitably happens is you got to go back to the start and do it all over again. You find out, you get a few cases that you pick up at the end, which are respondents, or they're non-respondents, or it takes you a long time to resolve the status of every case. So you often have to go back to the top and just do some of these adjustment steps over again. So it's critical that you be really organized about this and have a flow chart kind of like this in advance to refer to. All right, so that's that. And let's talk about base weights. Base weights in a probability sample are also called sampling weights, design weights, selection weights. You'll hear all those terms. And they're just the inverses of the selection probabilities of the units. So if you've got a simple random sample, if you pick little n out of cap n, the selection probability would be little n out of cap n. You invert that and you get cap n over little n. That's the simplest case. In general, I'm going to call these things 1 over pi I being the selection probability. And weights I'll call little d, d0i in this case for base weights. Now, sometimes it makes sense to draw a probability proportional to size sample, or at least something with varying probabilities. Like if you're sampling schools, you may want to give bigger schools a bigger chance of getting picked. So you assign a measure of size that's the enrollment, say, or maybe expenditures from last year. You can get that off some NCES files. The selection probability in this kind of sample would be the number of units you pick times the size you assign to unit I divided by, this is the number of units in the population, cap n, times the mean size in the population. So this n, cap n times x bar u is the total enrollment set for schools. And flip that over and you got a weight. So the units that have got big enrollment get a smaller weight. Sort of the intuition is there are fewer of them out there in the population, so they represent less. All right, so you keep track of those. If you do a multi-stage sample like HRS is, or panel survey for income dynamics, or family growth that Michigan does, there are a number of stages in picking an area sample. Keep track of the selection probability at every stage. Now, one thing that a lot of these household surveys get into, especially if you've got targets for number of Hispanics that you want to sample or number of African Americans, things like that, you differentially sample different kinds of households. And One thing that always happens to HRS in particular, which I know a little about, is you design a sample to hit your targets, and then you come up short for reasons that are hard to understand usually. So you got to go back out and sample some more. You supplement your sample. You better keep track of that too. Don't get confused. If you sample an extra batch of segments that you think are more heavily African American, you got to keep track of that. Otherwise, these base weights will get out of control. Yes, Paul.
We have a request for you to turn up the mic. Maybe just move it a little bit closer to your one button up. Yeah, maybe that'll be better.
Okay.
Great.
Let me try that.
Good, thank you.
All right, sorry. So everything I've said up to that point was a mystery to whoever sent that. All right, so here's some R code that'll draw a simple or stratified simple random sample and compute some weights. So let me back up the slide. If you do draw a stratified sample, the standard thing is to denote your strata by little h. So if it's a stratified simple random sample, you just compute these weights within a stratum. So pop size in stratum H divided by the sample size is your weight. So everybody in the stratum's got the same weight. It's really simple. Now, the thing that I use, or my old students convinced me to use because they made fun of me for not using it, is RStudio, which, does anybody else use that? Yeah, see, they cornered the market. For years they used this thing called RWinEDT, which I like because it's good for doing LaTeX code too, but the students would really sort of ridicule me, and you got to try to keep up, even if you get old. So this sounds like you're familiar with it. It's got a window up here where your code shows up. Got a window down here that's called the R console where things get executed. And then there's some bookkeeping things over here. If you draw plots, it'll show up over here. Plus there's some tabs that'll give you some other stuff. And if you want to get help on some function, that will show up, here in that help tab. So it's nice and it's free. There's this guy down at RStudio named Hadley Wickham. You ever bought any of his books? Yeah, he's really smart. He has written dozens of these R packages. So he's a real service to the profession. He's done so much at this point. All right, so here's my code up here for drawing stratified simple random sample. And this kind of header stuff, most people do it. I'd recommend this just for documenting your program. The file name's up here, the project you're working on, the purpose of the program I list, the date on which it was written, and the author. And then if you do revisions, put another line under here saying what the purpose of the revision was. So just to keep yourself straight. I don't know how you are, but I drop something for 6 months and come back to it. It's like a whole new world. I got to start over. All right, so here's how you load up a package. So I'm going to use the PracTools package and the sampling package. You can highlight those, do Control Enter, and those get executed down here. So it tells you down here they loaded them, and I'm rolled off. Maybe I can make this window a smidgen smaller. All right, so it loaded them successfully. If it doesn't do that, it'll let you know that too. there's a population or a data file object called NHIS that comes from the Health Interview Survey that I'm going to use that's in Prac Tools. So you say data to load that, and it just does it without telling you that it's okay. If it didn't find it, it'll tell you that. So we're going to use this variable in the file called educ_r. It's a recoded education variable. And this is one way to refer to a variable within an object. You say the object, NHIS in this case, $, and then the variable. And if you use R, you're probably familiar with that. So I've got 4 levels of that educ_r, and that's the count in each one. You don't want to create strata that have got very few cases in them unless you're really interested in those types of units. All right, so that's that, and then I need to use this sampling package. I need to sort the population in order by that stratifier. So one way to do it is this: use this order function, and then put the variable you're going to sort on, comma, and then nothing after it means I'm sorting on the rows. So that does the sort, and then I'm going to take a little tiny sample with 3, 4, 5, and 6 units from the strata, and the function in the sampling package that'll do this is called strata. So I highlight those, hit Control Enter, and it did it. Oh, didn't quite do it because it didn't highlight all of it. Try this. Okay, so one little point. There's the function that does this is called strata. So it takes some parameters, the population you're going to sample from. Strata names is the variable that defines the strata. But the point I want to make is in another package called survival, there's also a function called strata. If you load the survey package, which I'm going to use in a minute, it in turn will load the survival package because it uses stuff out of that. And if in the search path, the survival package is ahead of the sampling package, you're going to get an error that's totally confusing because you can't understand what it means when you first see it because you know you got this strata function available. So we may be the only people in the world that this happens to because we do surveys. So you can find the search path by doing this search function with open parentheses. So the way I am right now, here's its search path. It searches some global environment first. It searches the sampling package first, and then Prac Tools, and then some other stuff that gets loaded. So that's okay. It finds the right strata function if this is the search order. Now, if I load the survey package, the strata function in the sampling package is going to be masked. It will work anymore. Then you get mad, and at least my students used to get mad. All right, so that's that. Now, in this ST, what did I call that? STSRS. You can look at that STSRS object, and what it does is it draws the sample, it creates its own, or it extracts a unit ID that was out of the population file. And most importantly, it computes the probability of selection. So that's these numbers. So, you can verify that it did it right. If I go up here, the number of units in the first stratum is 1964, and my little sample drew 3 out of those. So 3 divided by 1964 is that 001527. So that here's some units picked from stratum 1, and that is their selection probability. So that's what it's doing. And then to get the weights, you just flip those over. So there's the line that does the survey weights. And it's a vector calculation. So it's with that, I've got to extract the observed data. So I've goofed up my file here. Well, in your file, there should be a line that extracts the data and puts it in something called SAMDAT. Yes.
So just taking a step back, because I think I'm just a little confused. So the design of this example is that you were sampling from different education strata, and so we're creating weights to recapitulate the original distribution of education in the possible sample. I'm just trying to get a bird's eye view of this, like the original.
Let me, it's nice to be able to draw on something. Let me see if this thing will work. On something there already. So if I have a sample of little n out of cap n, so that's my weight for each unit. Now, if I sum the weights up across all the little n sample units, so I sum, I equals 1 to little n, they're all the same. So it's going to be little n times that cap n over little n. So the weights sum up to the population size. So in that sense, you can blow up your sample to the population. The sum of the weights in your sample is either exactly equal to the number of units in the population or an estimate of it. Depends on how you pick the sample. So what we do is we take this idea, and it's possible to take other data items like, you ask everybody, are you employed or not? And you take the weight times that 0, 1 thing, are you employed? Sum those up, you got an estimate of the number of people who are employed in the population. So that's the idea of the weights, is to, expand your sample up to whatever target population you want to represent.
But it's based on one or several characteristics, and in this example, it's education. Mm-hmm. Is that correct?
That's typical, okay. Yeah.
Okay.
Yeah, usually, a simple random sample where you don't distinguish between different kinds of units when you pick the sample, it's pretty unusual. The more you know in advance, better a sample you can design. That's the idea.
Question from the chat kind of follows on to this idea. Basically, what are some tools we can do if we're using like an online panel where we don't know the full panel population from which the responses are sampled? I think you're going to cover this later, but this is kind of getting at what we do like where we don't know the full panel population, and we sort of just have a convenient sample.
Oh, how do you weight it? Well, you need to think about what kind of population you want to represent. You can't get out of that. I mean, even with an online panel where you're just computing things like proportions, like how many people are going to vote for a certain candidate in the next election. You can compute an unweighted proportion and it looks like it estimates something. But if your online panel by age, race, and sex of the typical voting population is not, if your panel distribution looks a whole lot different than the distribution of the population you're trying to represent, then you'd better weight the thing, as best you can. That requires you to think about the population you're trying to represent. And that in turn is going to require you to think about, is this panel a decent sample from the population I want to represent? Suppose your panel's got, no young black males in it. They're harder to get into these volunteer panels. Well, if that's the case, you can't say that you represent that chunk of the voting population. So, this is a long way of saying you need to think about what population you're trying to blow that panel up to. And then you need to apply some weights that'll do it for you if you're confident that it makes sense to do the expansion. Anything else? Yes.
Can you please explain what this function strata is doing exactly? Because I maybe missed something in your whole response.
Which function?
Strata?
Strata? Yeah.
Line 19.
Yeah. It's the first parameter that it takes is the population that you're drawing the sample from. So up here, I define POP to be just the sorted version of this health interview survey. I sorted it in straight order. And then strata names defines the stratifying variable. And then this continues down here. Size is the number of units I'm going to pick from each stratum. So I defined a vector. 3, 4, 5, 6 is the number that I'll pick from each of the 4 strata. And then this method is how I'll do the picking. So SRSWOR means stratified simple random sample without replacement. And because I'm doing it with strata, it does that within each strata. So it's got a bunch of other options too for how you pick them. That answer?
Yes. I'm just, but if you can just describe what is the overall goal of this function, what is your goal with this, applying this function to this data?
What it does is, down here in this window, I listed the sample. So let me do this, this function called dim. So if I say dim of the object, it's got 18 rows. So 3 plus 4 plus 5 plus 6 is 18. That's the grand total sample. And 4 is the number of columns, which is just these variables here. So if we look here, in stratum 1, I've got 1, 2, 3 sample units. So those are the 3 I picked. And then in stratum 2, I've got 1, 2, 3, 4 sample units. Those are the ones that picked. if I look at the population that's up here, here are the counts, the capital NHs in each stratum. So I picked 3 by simple random sampling out of this 1,964, 4 by simple random sampling out of the 719, and so on. So that's what that function's accomplishing for you. It draws the whole sample all at once. Yes?
So this vector that you created, the NH, it shows an arbitrary number that you chose to show us, or does it correspond to any predetermined criteria?
This little NH,
Yeah.
it's just an illustration.
Oh, okay.
It was, no thought was put into how many. It's, the numbers are small enough that I could list the sample and show you what it looked like. So there are good ways of figuring out how many you pick, but I'm not going to talk about that. Okay, so let's continue here. So that illustrates how you pull a simple random sample. Here's some data code, which I'm going to skip through. But it does work. So you Stata users can, well, one thing you need to do is you need to have access to the file. And on the Stata Press website or Stata website somewhere, there are all the data sets that are used in that survey weighting book that I referred to. And this NIHIS.DTA is just a Stata version of this data set, NHIS, out of the R package. So they're the same thing. Okay, let's see. This is an exercise which maybe I'll sort of talk you through this thing and you can tell me how to answer these questions. So suppose I've got a little population with 5 strata. It's business establishments, and my strata are types of business, like manufacturing, retail, wholesale, service, and finance. And here are my population sizes. Nice round numbers to make it easy. So I've got a population of 50,000 establishments, and I want to pick, it says calculate a proportional allocation for the 5-stratum design using an overall sampling rate of 5%. So what's your overall sample size? Say again? 50,000. That's the population size.
Oh, sample size.
So if I pick 5% of those, that's 500. Yeah, 2,500. So that would be the grand total sample size. And it says do a proportional allocation, which just means you sample at the same rate in every stratum. So if I take 5% of this, what is that? 300. 5% of that is 750, I guess. Those will add up to 2,500. And now calculate the base weight. So what's the base weight in stratum 1, for instance? 20. Yeah, it's 6,000 divided by 300. Or looked at another way, Yeah, I'm picking 5% of everything. So I flip over 0.05 and I get 20. So this is an especially simple setup. What's the weight for all the units in stratum 2? 20 still, because I'm picking 5% of each stratum. So it's always the same. Now, how would you go about verifying that you calculated your weights correctly once you go through that? The idea is
Sum to the strata size?
that's right, yeah. The weights ought to sum to the stratum size. And like it's the same thing as this, but within each stratum. So with simple random sampling, the sum of the weights is going to be the pop size. So you go through, you calculate your weights, and then you just sum within each stratum to make sure that you reproduce these numbers. It's an easy check, but it's one you ought to do. And it's especially important if you've gone through, some gyrations like supplementing the sample to make sure you got enough African Americans or something like that. You better sum up those initial weights to make sure they still make sense compared to what you think they ought to look like. So, good survey organizations like SRO routinely do this. This is like baked into their procedures to make sure they got that right. Okay, I'm ready to go on to non-response adjustments. Any questions here or out there in TV land? Nope. All right. Okay.
Can you just go over one more time why the base weight for each of those is 20?
It's let me go back here. Now let me go to, so I got 6,000 in the first stratum. So let me hit the drawing board here. So my first pop count in stratum 1 is 6,000. And I'm going to pick 5% of that. So I do, 0.05 times this thing, or just divide it by 20. So that, what is that? That is 300. And then my weight in stratum 1 is pop size over sample size. So that's 6,000 over 300, right? Hard to draw with this thing. And that's 20. So let me say a couple of things. This this number is the same for every one of those 300 units. They all have exactly the same weight. It's really uncomplicated. That would not be true in general. They could all be different. It depends on how you pick the sample. Mm-hmm.